How do we measure heat? Okay. Assuming there is no chemical or physical change, there's no phase change, and there's no phase change. That means there's no changing from solid to liquid or liquid to gas. Those are phase changes. So assuming no phase changes and there's no chemical reaction happening, heat flow will cause a temperature change in your system. The amount of heat, we say, is we're going to use the measured change in temperature as a way of measuring the amount of heat. We say that the amount of heat is directly proportional to the change in the temperature. In other words, if you observe a bigger change in temperature, means you put in more heat, right? So a bigger delta T would give you a larger Q. Delta T, the change in temperature, is final minus initial. And note that this is a change in temperature, so delta T, the unit for delta T can be degrees Celsius or Kelvin, and it will have the same value whether you express it in Celsius or Kelvin. Why is that? Let's say you went from 20, let's say from 0 degrees Celsius to 5 degrees Celsius. What's delta T for that one? That's 5 minus 0. 5 degrees, right? But what would that be in Kelvin? What's 0 degrees in Kelvin? 273, right? And what's 5 degrees in Kelvin? 5 plus 273 is 278. So what's delta T in Kelvin? It's also 5 Kelvin, okay? So keep that in mind. Anytime you're looking at temperature changes, whatever the temperature changes in Celsius, that's the same temperature change in Kelvin, okay? So delta T is final temperature minus initial temperature. This proportionality constant here, the C, is called the heat capacity of your system. That you can define that as the heat needed to increase the temperature of your system by 1 degree. Here's a way of looking at it. If we rearrange this equation right here, okay, we can solve for C. C is Q divided by delta T. So the unit for that is what? An energy unit, which is joules per Kelvin, temperature unit. Okay, that would be our unit. Or you can say it's joules per degree Celsius. So that's your heat capacity. So that's the amount of energy in joules needed to cause a temperature change of 1 degree Celsius or 1 Kelvin. All right. Unit for Q is calories or joules, and 1 calorie is 4.184 joules. Okay. Maybe if you're wondering why that odd conversion factor, that's because the calorie was defined first as the energy needed to change the temperature of 1 gram of water by 1 degree Celsius. Okay? And it was only later that James Joule was able to establish that heat is just another way of transferring energy. It's equivalent, and they've already defined energy units. And so the equivalent unit for the equivalent amount of energy for 1 calorie was found to be 4.184 joules. Okay. So let's look at some simple examples. Let's say it takes 8.4 times 10 to the third joules of heat to raise the temperature of a sample of water from 25 to 35 degrees Celsius. What's the heat capacity of the water? What's our formula for heat capacity? Capacity is Q over delta T. Give you a couple of minutes, not a couple of minutes, should take you only like 20 seconds to figure it out, right? So anytime you're ready, click your answer. Okay, let's see. Q is how much? 8.4 times 10 to the third joules. And the temperature change, T final minus T initial, that's 10.0 degrees Celsius. So 8.4 times 10 to the third divided by 10 would be 8.4 times 10 to the 2 sig figs, joule per degree Celsius. So it's A. Joule per degree Celsius is the same thing as joules per Kelvin or joules Kelvin to the -1. Okay? Same unit. Okay, heat capacity of a metal is 25 joules per Kelvin. Calculate Q if its temperature drops from 20 to 16 degrees. Assume no chemical or phase change. What is Q? What's the formula for Q? Q equals C delta T. Anytime you're ready, click your answer. What is it? D is a popular answer. Let's see if D is the correct answer. Q equals heat capacity is 25.0 joules per Kelvin. And delta T is 16.0 degrees Celsius minus 20.0 degrees Celsius. Okay. So that's 25.0 joules per Kelvin. 16 minus 20 is -4.0 degrees Celsius. Okay, a change of 1 degree Celsius is equivalent to a change of 1 Kelvin. So we do that just for unit consistency so that you can cancel Kelvin over here. So -4 times 20 would be -100, 2 sig figs, okay, joules. So -1.0 times 10 to the 2 joules. Answer is D. Okay.